Hey everyone, so today we're going to be solving this problem which states on page 207 there is a photograph of a girl pushing a large stone spear, which I've represented using the figure below. I'll explain a little more about it later on. The spear has a mass of 8,200 kilograms and a radius of 90 centimeters. Suppose that she pushes on the spear tangent to its surface, so linearly, with a steady force of 50 newtons and that the pressurized water provides a frictionless support. How long will it take her to rotate the sphere one time, starting from rest? All right, so it might not make sense regarding the pressurized water, but basically, there's no friction, right? That's all we need to really care about in this situation. And also, this is not a real force. I just drew it for illustration purposes. Basically, you have this person who's pushing, sort of rotating a ball that's going to stay stationary, right? But it's just going to be rotating around its axis. And so the point of contact of the hands is really where that force is being exerted because it's tangent, right? It's a tangent force, so there's just one point of contact. So yeah, let's just get into solving the problems. The first thing I want to do is make the connection between the torque equations. So you have sum of all the torque is equivalent to distance from the pivot point multiplied by the perpendicular force. And then you also have some of the torque is equivalent to the moment of inertia times the angular acceleration. And so these two equations come in pretty helpful for solving this problem because the first thing we can do is calculate the net torque, right? So we can use the net torque equation here and we can just use what's given. So the radius is 90 centimeters, which converts to 0.9 meters, right? And so we can just plug it into the equation. So our net torque would be the radius, or the distance from the pivot point, which is the radius, multiplied by the force. In our case, the force is a steady 50 newtons. And that will give us 45 newton meters. All right, so now we know our net torque. So now we can use this net torque value in this other equation. And why is this helpful? Because we can calculate the moment of inertia because the equation should be given to you based on AP Physics 1 standards. And then when we find the angular acceleration, then we can use angular kinematics in order to find the time, and I'll show you how to do that right now. So the first thing I want to do is find that moment of inertia. So there should be provided as reference for you all that the equation for a moment of inertia for a sphere is going to be 2/5 is that coefficient times the mass times the radius squared. And so we know a bunch of these numbers already, right? So first let's just plug this back into this equation. So the net torque we know is 45 newton meters. And the moment of inertia is 2/5 times the mass. The mass is given as 8,200 kilograms times the radius squared. And the radius we know is 0.9 meters. So 0.9 squared. And that's multiplied by the angular acceleration. So now we can just isolate, right? We can just divide by the moment of inertia to get the angular acceleration. So we have 45 divided by 2/5 times 8,200 times 0.9 squared. And that should give us the angular acceleration, which is around 0.016938 radians per second squared, around that. So using this angular acceleration value, I think I'll change colors for this. Let's use this green. Now we can use angular kinematics, and I'll show you why. You have to do a little calculation here. So the equation we're going to use is sum of the displacement is going to be equivalent to initial angular velocity times time plus 1/2 times angular velocity t squared. And so, since it starts from rest, because it says how long will it take her to rotate the sphere one time starting from rest. So if it's starting from rest, this initial angular velocity will be 0. And so this entire value will be 0. So now we only have to worry about this part. And now we want to know what is the angular displacement, right? So we can just do a little algebra and isolate for t. So we can just multiply 2 on both sides to cancel out the 1/2. So now we have 2 times the displacement equals angular acceleration u squared. Now we can divide by angular acceleration on both sides. And we get this. And now just to cancel out the t squared, we can just take the square root of the entire thing equals t. And the displacement would be 2 pi radians, right? Because it says to rotate the sphere 1 time. So if you rotate it 1 time, that's going to be 2 radians. And so pi equals 2 radians, 2 pi radians. And so 2 times 2 pi over the angular acceleration, which was 0.016938. And that should give us the value of time. And that value of time is about 27.23 seconds, which rounds to about 27 seconds to rotate that stone 1 time. And yeah, that does it for the video. If you guys have a question, drop it down in the comments below, and thank you for watching.